This is 16.2.2, the work half of line integrals, and this one's number 15. And the way these problems go is it talks about the movement of an object that's subject to a force along a path. So the object is going to move from 1, 1 to 4, 8 along this path, t squared t cubed, so that's a curve, and it's subject to this force. Of course, the definition of work is it's the integral of f dotted with ds. And of course, in our case, the ds is going to be along the r. So it's really f dot dr. So let's break it down step by step. And of course, this will be along a curved path. So first, what is f? Well, f is x squared times the sine of y. And then we're going to dot this with ds. So ds is going to be dr. So let's look at r prime. R prime is going to be 2t and 3t squared. So that's our integral path, 2t and 3t squared. Now, of course, when I evaluate this dot product, we're going to get x's and y's mixed in with the t's. So one of the first things I've got to do is replace the x and y. Of course, they're t squared and t cubed respectively. So now I can start writing things in. The final thing we need are the limits. If I'm going to write this all in terms of t, to get from 1, 1 to 4, 8 along this path, I need to start at t equals 1, and I need to finish at t equals 2. And you'll notice that produces this endpoint. So my t value ranges from 1 to 2. So that'll be the limits of integration. So from 1 to 2, and then let's rewrite this and do the dot product at the same time. So x squared is really going to be t to the 4th. And then that's times 2t. So there's the dot product of the front half, all in terms of t. And then we'll add on to that, sine y is going to be sine of t cubed. And then that's going to be times 3t squared. And you'll notice that's nice for integration because, you know, there's the derivative of the argument of sine. And then the whole thing is a dt integral. So that should be it. We've done the dot product. We've done the replacements of the parameters. We're now ready to evaluate it. It should be a scalar because we're evaluating work and the change in energy is a scalar. So once we evaluate this, both halves of it, we dump in the limits of integration. We're going to end up with 21 minus cosine of 1 minus cosine of 8. And that's it. That's the amount of work done by an object subject to this force that travels along this path.